Hello, I'm Marc Desgroseilliers from Technical Support here at Pix4D, and today we're talking about Sequoia. Sequoia is the multispectral camera from Parrot, and it is typically used for agriculture projects. In most agriculture projects, the aim is to measure the reflectance of the different regions of the field, and this is done by using a specific camera. And typically there are two types of cameras that are going to be used, either modified cameras or multispectral cameras. Now, what's the difference between those? The modified camera is just a regular RGB camera where the filters in front of the lens are going to be swapped out, so they're going to install new filters, which is going to change the wavelengths that are measured by the camera. So instead of RGB, typically it's going to be near infrared, red and green, for example. And two things to keep in mind about these modified cameras is that they are broadband. What I mean by this is that for agriculture project, typically you're interested at the reflectance at a very specific wavelength, say 790 nanometers. And these cameras, so then you want the reflectance at this wavelength, and the modified camera is going to measure the energy in an interval around this wavelength, which is going to be let's say larger than the other camera, than the multispectral camera. So that's what we mean by broadband. It's going to integrate over a wider interval the amount of energy in this interval. The other thing that modified cameras do is that they're going to apply digital filters. What this means is that the sensor is going to record some data, and then before it is saved in the memory of the camera, the SD card for example, some digital filters are going to be applied. This means that the data is going to be changed. These filters are applied by the camera firmware, so that these images that were meant to be taken RGB, they look better. They're more visually pleasing. So for example, the green really looks like the green that was taken when the shot was taken. But these digital filters, they modify the data, and so they make it more difficult to interpret it afterwards. Now, this is not the case for the second type of camera, which are multispectral cameras, because typically each sensor is going to measure just one wavelength, and these digital filters are not going to be applied because these cameras were specifically designed to record the data as it was measured. And the sensor, they're typically going to be also narrow band. So because we're interested at the reflectance at this 790 nanometers, the sensor is going to measure the information just in a narrow interval around this wavelength. Another thing about multispectral cameras is that since they were designed and engineered for agriculture purposes, they will typically write all the necessary radiometric data in the EXIF of the images, so that these can be taken into account and you can compute the reflectance from the images that were taken. So this is where I introduce Sequoia. So it's in two parts. There's the camera and there's the sunshine sensor. The camera has 4 narrowband sensors and 1 RGB sensor at the bottom here. And there's also the sunshine sensor, which is going to measure the illumination. And in the sunshine sensor, there is also the GPS module and the IMU. So this is what Sequoia looks like. About the sunshine sensor. So it's going to record the irradiance, the amount of irradiance coming from the sun for each picture and for each band. And what this will allow to do is to normalize the data amongst between the different shots. What I mean by this is that maybe the illumination, the amount of illumination changes during the flight, so that all of a sudden, at the end of the flight, there is more light coming from the sun, and so there's going to be more light, more photons that are captured by the camera, but then that doesn't mean that the reflectance of this region of the field was higher. It just means that the total amount of photons that was emitted was higher. So then this illumination sensor allows you to take this into account and to normalize the value of the images amongst themselves. Once you receive Sequoia in the mail, probably the first thing you'll want to do is to mount it on your drone. There are integration kits that are available for the EB from SenseFly and also for the DJI Phantom 3 and the 3DR Solo. If you want to mount Sequoia on your own drone, which is not one of those drones, or you don't want to use this integration kit, you should keep in mind that you will need to power Sequoia. It requires 5 volts and 2.4 amps. So that is if you have an external battery. And one thing that we want to bring to your attention is that right now there are plans that are available on the internet for 3D printing a universal mount for Sequoia. And when you put the camera and the sunshine sensor on your drone, it's important to have the camera facing down so that you can measure your field, and to have the sunshine sensor pointing in the opposite direction towards the sky. So once you've set this up, you will want to connect to Sequoia to change the settings. You can do this by connecting to Sequoia via Wi-Fi. And after the flight, when you want to connect to Sequoia to download the images, you can either connect to it via Wi-Fi or with the cable, or you can also just take out the SD card if it was recorded on if the images were recorded on the SD card. So let's see now on the computer what are the exact steps to take to connect to Sequoia via Wi-Fi and change the settings. Let me now connect the Sequoia to the computer, which will also power it. It should be recognized by the computer in a few seconds. There you go. Let me connect to Sequoia via Wi-Fi, and this is how I can change the settings of the Sequoia. Here you go. So I open a browser. I go to the address that was written on the slides. Here we are. Here I can choose how to record the images, whether on the internal memory or on the SD card. And I can also choose which sensors are going to be used. So for example, I just want multispectral imagery, or I just need RGB. And here in the capture window, I can choose the mode, so either single picture, time lapse, so a picture every X seconds, GPS mode, which will depend on the position of the Sequoia, so how far it has traveled, or just auto mode with overlap here. So for example, if I choose time lapse mode, then I have a handy calculator, and I can write the speed of my drone, the height, and then the overlap desired, and it will compute. So let's say 10 meters per second, and at 70 meters, and I want an overlap of 80%. And here you go. And I click apply, and now you see it will take a picture every 1.3 seconds. Now if I try to, there is a lower limit, so let's say that I try to put 0.3, then it will not accept this value because it's too low, and it will bring it back to the minimum, in this case is 1. So this minimum value will depend on 2 factors. It will depend on whether the pictures are saved to internal memory or to the SD card. It's quicker to save to internal memory if you want to take more pictures faster. and also which sensors are activated. So for example, if just the multispectral sensors are activated and you don't take RGB imagery, then you will be able to set a lower time-lapse interval. So here, that was for the first window. Now you can also go in the other tabs, so the current status of Sequoia. You can look at the galleries, so I took a few pictures before, change the folder, and you have the help and the settings where you can reset to factory settings, for example. That's what it looks like when you connect in through the browser to change the options. Here you can also download the imagery, but Sequoia will also be recognized as a camera. So if you go in the file in the folder manager, then you can also look here and you see Sequoia, which is going to be seen as a drive, and you can see your imagery and download your imagery from here. Let's see how to create the project once we have the Sequoia imagery. So here I have my images, and you can see what I like to do is I like to sort them and put them in folders according to whether they're RGB or multispectral. The easiest way to do this is just to sort by file type, because here I have my TIFF imagery, which is multispectral. So I just put that in my folder. And the JPEG images are the RGB. There you go. That will make my life a little bit easier. Now I can launch the mapper. And create a new project. Sequoia multispectral. So I'll just create the multispectral project. Add the images. Sequoia multispectral. You can choose all of them. Next, as you can see, there is one camera that's created for each of the multispectral sensors. They are connected by the rig geometry. I click next, everything looks good. The coordinate system is automatically detected. Next, and now I'm going to choose AG multispectral because I'm processing the multispectral imagery. If I was processing the RGB project, then I would choose here AG RGB. But here I want AG multispectral and finish. So here's my project. Now, about the calibration target. If you are using version 2.2 of the software and the firmware of the Sequoia is version 1.1 at least, then the calibration images will be recognized automatically and the region is selected and the calibration target is taken care of automatically. If this is not the case, then you should do it manually. One important note to make sure that it's done automatically is that the calibration target which is recognized is the IRINOV one. If you're using another calibration target, then it will not be recognized automatically. And then you would have to do it by hand, as I can show you now. So I go in the processing options, I go in the DSM, orthomosaic, and index, so for the third step, and in the index calculator. I have here my 4 sensors, and I need to calibrate each of them. I do this in the following way. I choose calibrate, I browse to find in my multispectral imagery. Now as you can see, I'm calibrating the green sensor. So I take my green calibration image and I draw a region inside of the reflectance region of the target. And this number here, it's written on my target. I know what it is. In this case, it's 179, and I click calibrate. Okay, and I would do this for all of the sensors. So I would need to do this 3 more times. But I'm not going to do this here. Then I click OK. And since I chose the AG multispectral template, everything is pre-selected, all the processing options, and I can just click Start. That's how you start your project with the Sequoia imagery. In many of these agriculture projects, you might want to use a calibration target to be able to compare datasets that were flown during different days. Now, to use a calibration target, it's important to keep a few things in mind. First thing is that the target should be flat on the ground, not tilted. If it's a handheld target, such as the Irinov one, you will want to take pictures of it either right before or right after the flight, and we recommend taking a few pictures just to make sure that at least one set of imagery is good and can be used for calibration. One common pitfall is that the target is going to be either underexposed or overexposed. If the target is overexposed, it cannot be used for calibration. So it's important to make sure that one set of imagery looks good, and typically overexposure will happen if the background is very dark, and so the camera tries to compensate for it. So if you want to avoid this, you can see what works well for your project, but we would recommend trying to use some kind of light background for the calibration shot. It's also important to avoid shadows on the target, as this would change the reflectance of the target region. And as a side note, starting from version 2.2 of the mapper, the Irinov target is recognized automatically for Sequoia projects. And so you don't need to input the different values for the reflectance of the different bands. You just import the images in your project, and the calibration shots are recognized automatically, and your project is calibrated by itself. No need to input the values manually. So then, once you're done flying, you will extract the data either from the internal memory of Sequoia or from the SD card, download it on your computer, and process the data in Pix4Dmapper. One thing to keep in mind is that you should have two projects, one for the RGB imagery and one for the multispectral imagery. And these should be two projects, and you should just import the correct imagery in each project. And when you're processing, there are two templates to use. So for the multispectral imagery, it's the AG multispectral. And for the RGB imagery, the template is called AG RGB. And in this case, it's important to make sure that in the camera model, the linear rolling shutter model is selected. Once you've done the processing, you will get the output for your project. So in the case of RGB imagery, it's going to be the orthomosaic. And in the case of multispectral imagery, it's going to be the reflectance maps, from which you can get the index maps and the prescription maps. To see how to go from reflectance to index maps to a prescription map, well, this is what is done in the index calculator, and we have another video that explains this workflow, so we encourage you to go have a look to see how to use the index calculator to get the data that you're looking for. That's all I wanted to say about Sequoia today. I hope you found this video useful, and I'll see you in the next video.